Okay. Hey guys. First of all, I just want to say I'm making an executive decision, and because SEL was more, especially the handouts, I know it was more frustrating than I meant it to be. So I'm just gonna have you guys focus on that, and I'm gonna go over the homework problems from Mondays, and that's going to be our all we have for the week. Okay, so realistically speaking, all that's due. Okay, so on by Sunday night, I need you to show me that you did the SEL stuff. Okay, so whether it's posting pictures or writing on a Google Doc, or even if you need to summarize it, go for it. Okay, I want it to be as easy as possible. I'm really hoping that you guys are getting some positive stuff out of it. So that's my main thing for you guys. Okay. Also, all right, as we go forward with all of this stuff in our calculus class, this is a time and an opportunity for you guys to really take ownership of your own learning. Okay. I'm gonna be real honest with you guys. It's gonna be a lot up to you. Okay. I'm not gonna have you guys be turning in a whole lot. I'm not gonna be doing tests because I can't I can't make sure they're secure. Like, I don't know, you guys can take pictures and pass it around and all that good stuff. So I haven't quite decided what I'm going to do for like assessment stuff. But now's the time where like take ownership. Okay. Your grades are not going to go down. They're not. Okay. So now is the time to really try to learn it. All right. Do the work and your grade will go up. It's as easy as that. Okay. I hope you learn stuff. I really do. But if you're doing what I'm asking you to do, and I'm going to try to keep it to a minimum, okay, you're going to do good. You're going to do fine. Your grade's going to go up, all right? No one is going to finish this year with an F. I'm hoping no one finishes this year with a D, okay? But put in the work, put in the effort, and I really hope you guys learn along the way, okay? So let's get to this. Sorry for taking so long to say that, but it's just been on my heart, that I just don't want you guys to stress. I don't want you to worry, but I do want you to learn, okay? So do your best, and I hope you guys can just kind of learn some of this stuff, okay? So an object moving along the x-axis. So this is this is Monday's homework. This should be on page 2 of your little online learning notebook, okay? So number 3. An object is moving along the x-axis such that its position function is defined as x of t equals t times e to the t. Okay, so for when t is greater than or equal to 0, it's because it's time. Time won't be negative. Okay, so find v of t and then find a of t. To go from position to acceleration, okay, it goes position, then its derivative is velocity, and then its derivative is the acceleration. So what we're going to do is we're going to take our, our position function, and we're going to take the derivative of it to get velocity, and then that'll be our velocity answer, and then we're going to take the derivative again to get our acceleration answer. Okay, so I have product rule here, which is what I kind of said before. So my little side work is going to be that my F is T and my G is e to the T. Okay. F prime, so the derivative of T is just 1. And then the derivative of e to the T is just e to the T. Okay. So when you do your velocity function, we're going to do product rule. So we'll go our first times the derivative of the second plus the second times the derivative of the first. Okay. I would simplify this. Ooh, that's a v of t equals t e to the t plus e to the t. Okay. That's good. I would notice that both terms have an e to the t, and so I would factor that e to the t out. So e to the t times t plus 1. Sorry, it's kind of ugly. But anyways, so that would be my beautiful simplified velocity function. Okay, so then when I do my acceleration, I need to take the derivative of my velocity. Okay, so again, I notice it's e to the t times t plus 1. So it has two functions again being multiplied, so I use product rule. My first term is e to the t. Its derivative is e to the t. My second term is t plus 1. Its derivative is just 1. Because the derivative of t is 1, and then the derivative of 1 is 0. Okay, so now I take a of t equals, I do my product rule, so first times the derivative of the second plus the second, oops, sorry, the second is t plus 1, sorry, times the derivative of the first. Okay, and then I'd notice that these terms both have an e to the t again, so I'd factor that out. E to the t times, from this term I'd be left with the 1. From this term I'd be left with t plus 1. Okay, so a of t equals e to the t times t plus 2. Because I added the 1. Oh, so annoying. Sorry. Oh my gosh, I messed it up. Oh well. It was a t plus 1, right? We already knew that. So I added the 1 plus 1 to get the 2. Sorry. Okay. B, for what value of t is v of t equal to 0? So what does it mean for the velocity to be 0? This means that the object is stopped. Because if it has no speed or velocity, the velocity is 0, it's stopped. That says stopped. Fun. Okay. Anyways, okay, so for what value of t is v of t equal to 0? So we take our v of t, which was e to the t, times t plus 1, and we set it equal to 0. And now we solve, okay? It's a product, right? E to the t times t plus 1. So we can set each of those equal to 0 and solve for t. So t plus 1 equals 0. Now, that one's easy, right? Minus 1, minus 1. So t equals -1. However, t is time, right? And time can't be negative. So when I'm in like a real problem here and it's asking like, oh, at what time is my object stopped? -1 is not going to be my, it doesn't make sense for like an actual velocity problem if t is time, okay? So keep that in mind. And then here, to get t by itself, we need to get rid of that e. So we're going to ln both sides. Okay, And so those cancel, and t equals 1, right? Is that one of 0, 1? Should have my calculator ready. Shoo. Oh my goodness. ln of 0. Oh, I get an error. I give up. I'm done. I'm tired. ln. Guys, what does ln look like? I wish I was in class with you guys right now. Is it just my phone calculator? Maybe I'm thinking of an exponential curve. Oh yeah, it is undefined. So this is error because it's negative. So that's what I want. Okay. So v of t said equal to 0 is -1. But again, for like if we had a word problem, it wouldn't make sense. Okay. But that's number 3. All right, on to the next one. Oh, yes, it went. Okay, number 4. An object is moving along the y-axis such that its position function is y of t equals t times ln of t, for t being greater than or equal to 0. Find v of 2 and a of 2. So in order to find those, I need to find the derivative of this. I have to first find v of t and a of t and then plug 2 into both of them. So here I have a product of 2 functions. So my side work, my first function is t. Its derivative is 1. My second function is ln of t. Its derivative is 1 over t. Okay, so you can kind of see already some stuff is going to cancel. All right, so v of t equals my first times the derivative of the second plus the second times the derivative of the first. So my t's cancel. So I'm left with v of t equals 1 plus ln of t. And then the question says to find v of 2. So v of 2 equals 1 plus ln of 2 plus 1 equals, so it's about 1.69. Okay, and then for a of 2, we have to take, to find the acceleration, we have to take the derivative of the velocity. So v of t is 1 plus ln of t, then a of t is the antiderivative, the derivative of 1 is 0, then the derivative of ln of t is 1 over t. So t, cute. And so to get a of 2, I just plug in the 2. And that's number 4. Okay. Okay, number 5. A of t is e to the t. V of 0 is -4. X of 0 is 1. Find an expression for velocity. Find an expression for position. And then tell me for what value of t is v of t equal to 3. So this one has a few parts. So this one, since I give you acceleration, okay, now I got to go backwards. So to go from acceleration to velocity to position, now I'm going backwards. So now it's antiderivatives, okay? So if I'm starting with acceleration, then I have to take the antiderivative of each to get the velocity, okay? So velocity equals the antiderivative of e to the t is just e to the t plus c, okay? And then that's what this information is for, is so that I can solve for the c and actually have a number. So if I plugged in t is 0, v of 0 is -4, so -4 equals e to the 0 plus c. Anything to the 0 power is 1 plus c equals -4 minus 1 minus 1. So my c equals -5. Okay, so my final answer for an expression for velocity, v of t equals e to the t, and then instead of plus c, I put -5 because the c equals -5. So that's my final answer for an expression for velocity. To get an expression for position, I do, now I'm going from velocity to position, so I need to take the antiderivative of the velocity, okay? So here I go, antiderivative of the velocity will give me my acceleration, my position, sorry. The t minus 5, so I'm taking the antiderivative of each of those. So s of t is normal for position. Again, the antiderivative of e to the t is just e to the t. The antiderivative of -5 is going to be -5t, and then plus c. Okay, and now I use this. I guess I should have put an x there because of the x there. So x of t. Okay, so now I use this top information and plug it in. So when for x of 0, that would be 1 equals e to the 0 minus 5 times 0, 0, plus c. So e to the 0 is 1. This is just 0. So then plus c equals 1 minus 1 minus 1. C equals 0. Okay, so my final answer for position in terms of time is x of t equals e to the t minus 5t, because my c was 0, so I don't write plus 0. Okay, and then the last piece of this problem was, for what value of t is v of t equal to 3? So v of t equals 3. That means we're using our velocity. V of t is 3. So 3 equals e to the t minus 5. So it's asking us to solve for t. Plus 5 plus 5. 8 equals e to the t. And then to get t by itself, ln t equals ln of 8 ln, so 2.1, because it's time, so seconds usually, so 2.1. And that is it. So that's number 5. It had 3 questions for us. And then number 6, it has 3 questions again. So finding v of t, y of t, we're going to use this information to get those. And then this time it asks me, in what direction is the object moving at t equals 9? So in what direction? My answer is either going to be right or left. Okay. All right, so here we go. A of t, so I'm going backwards again. So I'm doing antiderivatives. So a of t equals t to the negative 3 halves. Antiderivative of each of them. Antiderivative of a of t is v of t equals, when I am doing the antiderivative of this, I'm going to add 1. So add 1, which is just 2 over 2, right? Because it's a fraction. So I get t to the negative 1/2. Oh my gosh, guys. On the last one, I didn't divide by the new power. I have to go look back, but I'll do that after this. I'm tired, obviously. Okay, I'll double check the one after in just a second. Or the one before, I mean. Okay, so I had t to the negative 1/2. Add 1, divide by the new power, so multiply by the reciprocal since it's a fraction, and then plus c. Okay, so then use this information. So v of 4 is 2, so that means v of t is 2 when I plug in the 4. Okay, so negative 2 over, so negative exponents, right, my lovelies? This is a 2. Oh my gosh. Better. So negative exponent means we're going to drop it in the bottom, and it's a square root, right? I don't want the t because I'm plugging in a 4. So plugging in 4 plus c. So 2 equals negative 2 over 2, which is just negative 1, right? Plus c, add 1, 3 equals c. So final answer for v of t equals negative 2 t. Let me rewrite it on the bottom, sorry. Okay, I'm hoping I just stopped when I erased that because I accidentally pressed the pause button, so I hope that's when I pressed it. All right, so v of t equals negative 2 over square root of t, or you can do t to the 1/2, whatever, and then c equaled 3, so I would put plus 3. And that's my final one for the expression for v of t. Okay, then here's a fun hint. When you're doing the antiderivative, so we still need to find y of t. So we're going to do the antiderivative of v of t. Whoops. Eraser. I don't want this piece or that. Okay, so antiderivative of v of t equals the antiderivative of, I would write it like this already because it's in a fraction exponent. Like we want the exponent there. We don't want it as a radical because we're going to have to add 1, divide by the new power. So just do negative 2t to the negative 1/2 and then plus 3. Okay, so take the antiderivative. Antiderivative of velocity is position, so y of t, I picked a y because that's what it told me over here, equals, all right, so here we go, adding 1, so plus 2 over 2, and we're back to now t to the positive 1/2, dropping that negative 2 down. And don't forget to divide by my new power. And so since I'm dividing by 1/2, that is the same thing as multiplying by 2 over 1. Okay. We'll simplify that in a second. Antiderivative of 3 would be 3t. And then plus c. Simplify. So y of t equals negative 4 You can either do t to the 1/2 or square root of t, whatever you like, plus 3t plus c. Okay, now we're going to use this wonderful information. I'm so excited. It's zeros. So y of 0 equals 0. So 0 equals, when I plug in a 0 here, that's going to be 0. When I plug in a 0 here, that's going to be 0 plus c. And so c equals 0. So then my final expression for my y of t is just no c. Negative 4 t to the 1/2 plus 3t. Okay. And then the last piece it says is, what direction is the object moving at t equals 9? Direction, if you remember, it's based on the sign of velocity. Okay, so based on the sign of velocity, so if I plugged in 9 to my velocity function, if I plugged in 9 to my velocity function, that's a 9, not a q, I would have negative 2 over the square root of 9 plus 3, right? So here, square root of 9 is 3, so negative 2/3 plus 3. All I care about is the sign, right? Because it just asked me what direction is it going. And so since I care about the sign, this is a negative 2/3, so negative less than 1 plus a positive 3. That is going to be a positive value. Positive. Okay, so then what direction is it going? It's going to the right. Or up. Okay, so that's number 6. Real quick, I need to go back and look at number 5 because I freaked out a little bit about when I did the antiderivative. So let's look. Oh, good. It was just e to the t. Okay, so everything's good because it was e to the t and not a polynomial with the exponent. All right, guys. So that's it. Okay, that's it for the week. Ask me questions. I'm going to be on Zoom Thursday, which is tomorrow or today, if depending on when you're watching this, but it is currently 11:06 p.m. on Wednesday, so I'll have a Zoom on Thursday at, what did I say for you guys, 10? I don't remember. I wrote it down somewhere. I think you guys are at 10, right? So yeah, hopefully, let me know if you have any questions, and I hope you guys are having a wonderful day. Love you. Bye.